post this afterwards. All right.
Yep.
Okay, so so here's my version of this question. I got an angle that's coterminal. I want to find an angle that's coterminal with the angle 109 pi over 10 radians. So let's take a look at that. Let's write that down. And I'm going to do the negative version of this problem as well, because some people have each version of the problem. So so 109 pi over 10. Now, so what we're looking for in this angle between 0 and 2 pi. This angle is clearly not between 0 and 2 pi because 2 pi would be 20 pi over 10. So it's way bigger than I want. So what I do, my trick to this is I sort of ignore the pi, right? Because if we just, if you think about it, I'm going to subtract some multiple of pi that's even. So I'm going to subtract, let's just write it as, I'm going to subtract n pi, okay, to find my angle. I don't know what n is. It's some even numbers, 2 pi or 4 pi or 6 pi or 8 pi, something that's in even multiple of pi. Well, what I can do is I can factor out the pi, and I can really look at it as I'm going to subtract 109 over 10. I'm going to subtract something from that. And when I get my answer, I want the answer to that to be between 0 and 2 because I want it to be between 0 and 2 pi. Okay? So I'm going to take out my calculator here. I've said that it's not required to have the TI, but the TI is pretty nice for this one. I could do it with the Desmos calculator as well. It takes a second for the calculator to come up. But basically what I do is, the first thing I do is I'm going to change that 109 over 10 into a decimal number. And so once I do that, I'm thinking, okay, here we go. So I'm going to do 109, and I'm going to divide by 10. Okay, so it's 10.9. So what I want to do is, two angles are coterminal if they differ by a complete rotation. The angle of a complete rotation is 2 pi. So anytime I subtract an even multiple of pi, I'm coterminal. So what I want to do is I want to subtract the biggest even number I can, but still be positive. So in that case, that would just be 10. So I can subtract 10. That's an even number. It'll still be positive. But if I subtracted the next biggest even number, 12, I'd be negative. So of course, that's 0.9. And this is it's pretty straightforward how to change that back into a fraction. But if it wasn't, I would just press the math key, do number 1, and change it back to a fraction, which is 9/10. So the answer to this is, and I'm going to write it out with the work, 109 pi over 10, and then I'm going to subtract 10 pi, because when I subtracted 10, what I was really doing was subtracting 10 pi, because they're both in terms of the number of pi, and the answer is 9 pi over 10. And we can real quick verify that. Do my fraction, 9. You can actually put the pi next to the fraction or in the numerator. To get that pi, just type pi, or you can click the button. And then 10, click out of the box, and submit. All right. Now, what if this had been negative instead of positive? Because some of them are negative angles. Well, what I would do with my calculator is I would just find that negative decimal, negative 109 divided by 10. And now I still need to use even numbers, but now I need to add an even number, but I need to add a big enough even number to make it positive. So if I added 10 here, it would still be negative. So instead of 10, I'm going to add 12, because let's clear that. I'm going to add 12 because that will make it positive. So that would be 1.1. Go back to my math button, change it into a fraction. So that would be 11 pi over 10 if it had been that. So when you have a positive, you subtract the biggest even number you can to still stay positive. When you have a negative, you add the smallest even number you can that will turn it into a positive answer.
Okay.
But I ignore, you notice the whole time I wasn't having that pi there, because it's like basically I sort of put that pi off to the side while I was doing it and then brought it back in once I had worked with the coefficients.
Yeah.
All right. Okay. And what was the other one? You said there was 2, I think?
The other one was actually just the positive version of that.
So I did do the positive version of that. That was 7, but I thought there was another question number.
Okay, yeah, on 11, I
Okay.
got most of these right, where you have to find the coterminal angle
Yeah.
within 360 degrees and then the reference angle.
Uh-huh.
But I feel like my answer is correct, but it's telling me that it's wrong. So it
Why
was
don't so for this one, why don't you give me your original angle?
the angle was 311 degrees.
That's the original angle?
It was,
Go ahead.
sorry, 3,311.
3,311 degrees. Okay, I
Yeah.
like this. 3,311 degrees. Okay, so what I do here with degrees, I do it differently than I do with radians.
hmm
Because I don't, what I do is I figure out how many circles is this.
Yeah.
And the way I do that is I divide by 360,
Yeah.
right? Because there's 360 degrees in a circle. So this is about 9 circles, right? 9 and change.
Yeah.
So what I'm going to do is I'm going to subtract then 9 circles from that to find the coterminal angle. So
Yeah.
it's going to go 3,311 minus 9 times 360.
Yeah.
So 71 is my coterminal angle.
Yeah. So I got that part correct.
So
the second half is incorrect.
For the reference angle, in the first, you actually got lucky because for a reference angle in the first quadrant, the reference angle is the angle.
Oh, okay.
So the answer to the reference angle is 71 degrees. So let's actually real quick look.
See, I thought it was 19.
Okay, no. So the reference angle is always the angle that your terminal side makes with the x-axis. So if you're in the first quadrant, remember you measure an angle from the x-axis to your terminal side. So this is theta.
Yeah.
Well, in the first quadrant, theta is the angle with the x-axis. So theta is your reference angle.
Okay, so I was doing it wrong because I was using the y-axis.
Yeah, yeah.
Okay.
So if we look in the second quadrant, we might as well go around. All right. So that's theta is from the positive x-axis to your terminal side, but your reference angle, or theta prime, is that angle to the x-axis.
Okay.
Well, that would be equal to get that, I'd subtract 180 degrees minus theta.
The angle. Yeah.
Yep. And that would give it to me. Now, I'm going to erase that. If I was in the third quadrant, so my theta, again, is starting at the positive x-axis and going all the way around.
Mm-hmm.
My theta prime is just back to that x-axis, the closest x-axis. All right, so in this case, I would do my theta, because my theta is bigger than 180, I would do theta minus 180 degrees. Or everywhere I say 280 degrees, that would be pi if I was working with radians. Okay, so, and then if I was now into the fourth quadrant, my theta is all the way around. So it's from, it's going to be between 270 degrees and 360. My theta prime is back up to the x-axis. So that would be 360 degrees minus theta.
Okay.
Now, I hate it when like a student tries to memorize what that formula is in every quadrant.
Mm-hmm.
It's good to sort of have that as reference, but it's pretty, like once you look at it, it's pretty straightforward what that is. But the one thing also to remember about the reference angle is it's always between 0 and 90 degrees, or between 0 and pi over 2. Because if you're measuring to the closest part of the x-axis, it's always an acute angle, no matter where you are. The biggest it could be is 90 degrees if you were right on the y-axis, one way or the other. So the idea of a reference angle is it allows you to compare an angle that's not in the first quadrant to an angle that it is in the first quadrant. So the reference, the terminal side of the reference of the angle has the same x and y coordinates as an angle in the first quadrant, except for the signs are changed, right? The pluses and minuses are changed. So that's the reason why we look at reference angles. So, and that'll become more clear in module 2.
Okay. Yeah, I have like 5 more questions, so I just haven't gotten to them yet. But other than that, that's about.
Well, what I'll do then is I'll pause the recording, and I'll mute myself. But you can stay on the webinar. I mean, I'm going to run it for, I mean, it's only 15 more minutes, but you can do as many as you can in that time, and just jump back on, just unmute yourself if you come across something that you're like, ooh. So you may want and one thing you could do is just sort of scroll through them and see if there's anywhere you're like, ooh, I'm not even sure how I'd start that one. You could do that too as well. All right.
All right.
Okay.